Hello everybody, and welcome back to a Python mathematics and stock indicator tutorial video. In this video we're going to be discussing the average true range. Alphabetically, actually we would be discussing the directional movement system, but the directional movement system uses average true range within it, so that's why we're kind of skipping over that one to average true range, and the next little mini series will be the directional movement system. So ATR, what is it? It's another one developed by Wells Wilder. The idea of it is to measure volatility in a stock. So it's not going to denote trending at all. Sometimes it might appear like it is, but it is not. So the average in average true range just denotes it's just true range with an average, right? So it's an exponential moving average of true range. So what's true range? True range is just the difference between the absolute lowest price and the absolute highest price within a one-day time period. So it's usually going to be today's high minus today's low, or that specific day's high minus that specific day's low, but it can go all the way back to yesterday's closing price. So if yesterday's closing price was really, really high and then today's low is really, really low, and those are the max and min, then that would be considered. Mostly since that's like a true full 24-hour day of price. And in some theories, you would say that the price is still changing even while market is closed, because people's opinions, sentiment, and all that is changing. So true range is a measure of volatility, but it's only a measure of the absolute highest price to the absolute lowest price. So keep that in mind, because I would be one to argue that that's not a full definition of volatility. Really, the true volatility would be, as far as percent change, how much. Like how much did that stock go, or the whatever stock or forex ratio or whatever, how much did that go up and down and up and down and up and down throughout the day, right? Not necessarily just because it rose a lot, but what if in my opinion volatility is a lot of up and down. But anyway, you just have to kind of accept the fact that that's part of it. Now, average true range, I'm not the biggest fan of this, but the directional movement system that uses true range is actually a pretty interesting indicator, so I'll be interested to see what you guys think about that one. So moving on, just again, the average true range is just simply an exponential moving average, typically 14 of that true range. But again, one of the benefits to both knowing how to chart your own stocks and how to calculate this stuff is you can put whatever value in there you want. If you want to use a shorter, like I was saying in the beginning, the idea of moving averages is to fit your needs exactly. So you can smooth out a line to be either a very long-term kind of trend line or a very short-term trend. And 14 is kind of a longer-term trend for something like this one. And I'll show you some examples of comparing 14 to maybe like a 5, right? And you'll see the stark difference. And also the choosing of whether or not you even want to do an exponential moving average, because again, you might not want to do an exponential moving average. You might want to do just a typical moving average. And then even Wells Wilder himself had his own special, Wells Wilder moving average. So you can kind of you can choose a lot of your own things once you learn how to do this stuff. So it's definitely useful. Also, if you're the one programming it, that gives you a pretty good understanding of what's going on in the formula. And then you can really truly make an educated decision on whether or not you want to buy into that indicator. So now I'm just going to show you guys some examples of this average true range. I'll just show you a couple different stocks. The first one I want to do, we'll do a 14 period ATR of Exxon, and I'm just going to run that script here. And this is what we'll end up coding at the end if you follow all the way through. So we'll plot Exxon. It comes up in a second. Let me go grab it. And here's our Exxon chart. And as you can see, again, this is a ATR. Oh, let me fix that. It's an ATR 14 period. And here's a good example of where, obviously, you can, volume is a pretty good measure of volatility as well. I would almost say that of this stuff, volume is the better measure. And volume's like instant, right? You don't need any moving average. But anyway, and you can see how volume kind of correlates, or really ATR correlates to volume. Anyway, so here would be like one of the most volatile points on the chart. As we can see, it does show up here, but it's quite late. It doesn't show up until, way over here, right? So it starts showing up really on December 21st, and it peaks at January 11th of 2009, when really the true action, the true volatility was actually October 6th-ish to 10th. So as you can see, that's insanely late. But you can see also that this line was slowly rising as volatility was rising, and then you see it reached its peak, and then it kind of came down. And sure enough, price change in this area was a little bit slower than price change up here. So not to say that it doesn't work, but again, volume I think is a pretty good determinant. I mean, you could put a moving average on volume or just leave it like this, and you can visualize it just as good, in my opinion. So now let me show you another example, only this time, like this one's using an ATR 14. We'll do an ATR 5 on the same stock. Let me close out of this and edit the value there. So this one will be a 5, and we'll run it. We'll run Exxon. So here's our Exxon chart, and as you can see, this one worked out a lot better with it's still a little bit late, because again, it is using a 5-period exponential moving average. So let's just zoom in on this spot. So you can see it kind of just barely is missing it here, but it's much better. But then also, if we zoom out, we can see again, it's almost perfectly matching volume. So I know I keep saying it, but I just think volume's probably one of your best bets, or maybe a meshing of volume and price. But anyway, so that's the basics of ATR, and again, it's only to denote volatility. As you can see, I mean, it's doing its job at least, and then we can begin to use this to be a measure of volatility. And it's actually, considering that it doesn't use volume at all to measure volatility, I would say it's actually a pretty interesting indicator of volatility, because then you can mesh it with volume, and you're using two totally separate data sets. So it gives you a pretty good idea of what volatility is. And then when you mesh this with ATR, for example, just another case of what makes it so useful to know how to not only chart but also program this stuff, is you can change, because this is just true range, that in the point of true range is to measure volatility. So since that's your goal, you really could mesh this ATR with just simply percent change or something of volume, and you can really get a good measure of volatility. So then when you go to add it to maybe the directional movement system, you can make that system a better system. So in the next video, this is what we're going to be programming, or at least this line right here. That's all we're really after. We'll be programming that, and then in some subsequent videos I'll show you how to add it into the chart like this, so you can see the same thing. So anyways, that's going to conclude this introductory video to average true range. As always, thanks for watching.